So now we're going to go through how to balance redox reactions. These are one of my favorite types of reactions because it's very, very systematic. You follow the rules. As long as you know them and follow them in order, it'll work out. Plus, you can always check your work, so you'll always know when you get the answer correct. Here's our steps. We're going to write the skeleton equations for the oxidation reduction half reaction. So we're going to split our reaction into its two parts. We're going to balance all of the atoms except for hydrogen and oxygen. So anything else that's in the problem, nitrogen, phosphorus, carbon, you name it, anything as long as it's not hydrogen or oxygen. Then we'll balance our oxygen by adding H2O. Then we'll balance our hydrogens by adding H+. We're going to balance the charge by adding in electrons. So note they must always be on opposite sides of the reaction. So in my two half reactions, I'll balance them. The electrons have to be on the opposite side. That's because we need to cancel them out. I don't have a jar of electrons in the prep room for me to use to add to a reaction, so we can't actually have them in the overall reaction. You're going to balance the total number of electrons in the two half reactions by multiplying by the factor, finding the least common multiple of electrons lost and gained. It's a lot of words. We're basically saying multiply through until your electrons are equal. That way we can cancel them out so that we don't have them in the final equation. You're going to add your two half reactions and simplify, and then perform a check on the equation to make sure the number of atoms and the charge are balanced so that you can always check your work to know that it's correct. So let's take a look at this first reaction. The first thing that we always do is we assign oxidation numbers and we label our reducing and oxidizing agents and what's reduced and what's oxidized. What I'd like you to do is to write down this reaction and then to pause the video and to see if you can go ahead and get the oxidation numbers correct and correctly label the oxidizing agent, the reducing agent, what's oxidized and what's reduced. Okay, now check your work. Is that what you got for all of your oxidation numbers? And that's what you got for your agents and what's reduced and what's oxidized? If not, make sure you ask me about it in class so that you know. Now we're going to split our reaction into two half reactions. And to do this, I'm going to take my thing with nitrogen here and here, and these will be my half reactions that involve nitrogen. So I'll have HNO3, and basically I'm just picking things that are my reactants to my products, not worrying about hydrogen and oxygen. And that means my H3PO3, just to have it there, is going to become H3PO4. And there we go. Now, I like to go through all the steps for one half reaction, and then I go through them again for the second half reaction. So for my first half reaction, I'm going to balance my nitrogens. Well, they're already balanced. That's good. I'm going to balance my oxygens by adding H2O. I have 3 here. I have 1 here, so I'll add 2 H2O. I'm going to balance my hydrogens by adding H+. I have 4 here, and I have 1 here, so I'm going to add 3 H+. I'm going to balance my charge by adding electrons. No charge over here. Everything is neutral. My charge over here is +3. The number one mistake is to go ahead and add electrons over here. But that would make this side a -3 and this side a +3, which wouldn't be equal. So I'm going to go ahead and put my electrons here because -3 and +3 makes this side neutral, and now this side's neutral. If it's not working out, check that your electrons are on the proper side. It's by far the most common mistake. Now, let's do this one. My phosphoruses, they're balanced already. 3 oxygens here, 4 oxygens here, which means I need to add a water over here. I have 1, 2, 3, 4, 5 hydrogens over here, and I have 3 over here. So I'm going to add 2 H+'s here. Then I have a neutral charge here and a charge of +2 over here, which means I'll add my 2 electrons in over here. So my first check to see if I'm doing this correct has passed because I have electrons on the opposite sides of the arrows. They were on the same side and I added them together. Then I would be in trouble because I don't have any electrons to bring to the reaction. Now we have to make sure these electrons are equal so they cancel out. Well, I have a 3 and a 2, which means I have to multiply both of mine by a number. So I'm going to go through and I'm going to multiply these all by 2. So this becomes 6, this becomes 6, this becomes 2, this yes, multiplying all by 2, yep, and this becomes 4. So I doubled all this, now I have 6 electrons here. I need to do the same thing down here, but I need to multiply it by 3. So I multiply this by 3, this by 3, this by 3, this becomes 6, and this becomes 6. Now my electrons are equal, and so therefore they'll cancel out. I'll switch to a new color here. So I can cancel out my electrons, gone, and I can cancel out anything else that's on opposite sides. I have 3 H2Os, and this is where you have to be very, very neat, very, very organized, and you can't be scribbling and whatever because it gets confusing with all of this crossing out. So it takes your time, makes sense to go slow and be patient. So I have 3 H2Os, I'm going to cancel that out, and this is going to go down to 1. And I have 6 H pluses, and those will cancel out with these 6 H pluses. Now it's just time to sum up my problem. So what I have left is this, and this, and this, and this, and this, and I'm just going to recopy it. So 2HNO3 plus 3H3PO3 yields 2NO plus 1H2O plus, and I don't need to put the 1 in there. I did it up here so that I wouldn't forget that I had one, but I don't need to put it in the reaction. But I can, if you do, it's fine. And 3H3PO4. Now I can always check my work. Neutral, no charge, neutral, no charge. There's nothing with a charge in it. Check my hydrogens. I have 2, and I have 3 times 3, 9, so I have 11. I have 3 times 3, 9, and I have 11. I have oxygens. I have 2 times 3 is 6, and I have 3 times 3, which is 9, so I have 15. And here I have 3 times 4, which is 12, plus 1, 13, plus 2, 14, 15. Nitrogens I have 2, nitrogens I have 2, phosphorus I have 3, phosphorus I have 3. My reaction is balanced, and I know that it's done correctly. Let's try one more. Again, I want you to see if you can do the oxidizing and reducing and all of your oxidation numbers. So pause the video and make sure you can do those. Okay, did you get them correct? I hope you did. Did you remember that silver is an element by itself, so it's 0? Now, let's split our reactions into their half reactions. I'll start with my Ag. So Ag is going to become AgNO3. And then I'm going to take my HNO3 and have it become NO. Now I've covered all 4 of my compounds, so they're listed. I'm going to start with my top one and balance my Ags, and that's okay. The problem is here I have an N, and it's not balanced. Well, if I look over at the reactant side, I can't just put in N2. I can't just put in any other compound. The only thing I can use besides water and H+ is things that I already have in my reaction. So I do need to put this HNO3 also in this problem. I know it's down here. It's going to end up being added together at the end, but it's okay, and that's something that is allowed. So if you're stuck with an element that needs to be balanced, you have to look for it in something that you already have. So now let's check again. Ag balanced, nitrogen balanced. Oxygen 3, balanced. Hydrogen 1, hydrogen none, so I'll add an H+. Charge neutral, charge +1, so I'll add an electron. Let's check here. Nitrogen, good. Oxygen 3, oxygen 1, so I'll add 2 H2Os. Hydrogens 4, hydrogens 1, so I'll add 3 H pluses. Charge is neutral, charge is +3, 3 electrons added. Now I'm going to have to add my reactions together, but before I do that, I need to balance my electrons. That's going to happen here. So I have 3, I have 1, so I'll multiply this one through by 3, 3, 3, 3, and 3. And then I'll go ahead and cancel out. Those electrons have to cancel. Opposite sides, so I've passed my first good check. Hydrogens in this case cancel out. They may not always. Sometimes you'll have hydrogens in your final reaction, which is fine. And doesn't appear to be anything else that I can cancel out. But I can combine these two. So I actually have 4 HNO3 plus 3 Ag, which is going to become 3 AgNO3 plus NO plus 2H2O. And there we have it. Let's check our work to make sure we're right. I have 4 H's, I have 4 H's. I have 12 oxygens, I have 3 times 3 is 9, 10, and then 11, 12 oxygens. I have 4 nitrogens, and I have 3 times 1, plus another one, 4 nitrogens. I have 3 Ags, and I have 3 Ags. My charge is both neutral, and so it is balanced. And so the problem is complete. If you make a mistake somewhere in the problem and your final answer is not wrong, I highly, highly, highly recommend just starting over. This gets much, much, much too complicated to be able to try to undo it unless it's something very obvious very quickly. But really, your best time saver is to start it again and to do it over.